Today's video lesson is over translations. Translations is a type of transformation. A transformation means you change something, and translation means you slide. So translation does mean something a little bit different than it does when we're talking about like English, translating English to another language or something like that. In math, we talk about translations as a slide. So if we were sliding some of these dots here, this one says 4 units up, 2 units to the left. You might not have this paper, but I'm just going to show you a quick little introduction to what we do when we slide a figure in geometry. So 4 units up, 2 units to the left would take this dot going up 1, 2, 3, 4, 2 to the left, 1, 2, and the new dot would be here. So let's consider this old dot to be called A. The new dot would still be A, but it would be A with a little tick mark at the top called A prime, as in the new A. So let's try this next little dot here. It says 5 units to the right. That just means we would slide it 5 units to the right this way. And we count by the coordinate spots. So 1, 2, 3, 4. Oh, wow, good job, Miss Garza. 5. I counted wrong. That is the new spot. So pretend that we call this dot B. This dot would be B prime, as in the new object, new figure. Okay, let's get on to our notes. The notes page says transformational geometry because this unit is all about transformational geometry. Geometry deals with shapes and transformation deals with changing things. So basically we are changing these shapes to look a little different. All we're doing is translating them. Translation means to slide an object. Please write that down. If you have trouble remembering, translation has an SL, and I always consider the SL to stand for slide inside of translations. So the top says this says triangle ABC, so that is the name of this triangle here. It's translated 1 unit to the right and 4 units up. And then it wants us to draw the image triangle A prime, B prime, C prime, which is the new triangle after we do a translation of 1 unit to the right and 4 units up. So let's move to the right 1 unit for B and then go 4 units up. So 1 unit to the right, 4 units up, and make a dot. And of course, this is B prime. The next one is A. I would go 1 to the right, 4 units up. And this would be A prime. The next would be C, 1 unit to the right, 4 units up. And wherever it lands is the new C, C prime. So we consider this to be the pre-image because it is the image before the change, and this is the image or the new image. All right, so it says that it wants us to write the new coordinates. The old coordinates were already written for us, so that was nice of them. We're going to write the new coordinates now. All right, so let's figure out A prime is here. It is 2, 1. Remember, a coordinate is always X first, Y second. B prime is way up here. It would be 4, 4. And C prime is 5, 2. All right, so whenever it says that we are going to create a general rule, up here the notion or the little sentence in geometry says the triangle ABC changed, the arrow means changed, to ABCD or ABC prime, okay? So the new triangle. It says, as a general rule, this translation could be written. So basically what we do in math, instead of saying this whole long sentence, we would change the sentence to look like more like an equation. This is basically saying something, it's telling the story just in math terms. So it says XY. XY is a coordinate. The arrow means changes to X plus something and Y plus something. Now the reason they're saying plus a number is because these old coordinates right here became these new coordinates probably by adding a number. Anytime we move to the right, so let's pretend that let's focus on the B right here. The B went from, it was originally on the 3 on the x-axis, see? And now it's at the 4 on the x-axis. So it went over 1 because that's exactly what we told it to do. If we're going 1 to the right, we would technically take this number here and add 1 to it. Let's check to see if that was true. 1 plus 1 is 2, yeah. 4 plus 1 is 5. Okay, so anytime we're moving to the right, we are actually adding whatever number that we're moving. And let's talk about the y values. So we go up. Let's consider A down here. A was at a -3 on the y-axis to begin with. It does say that right here. And then A goes up all the way to become this point right here where it's at 1. So it went from -3 to 1, which is technically adding 4. We already knew that because we went up 4. But if we write it in an algebraic it's an algebraic way, it would be y plus 4, which basically means we could take every y value from the old picture and add 4 to it to create the new picture. So -3 plus 4 is 1. 0 plus 4 is 4. -2 plus 4 is 2. So it works. Anytime we are adding to the x, it means that we're going to the right. Anytime we go to the right, we add to the x. Anytime we add to the y, it means we're going up. It makes sense because the y coordinates are up and down, and the x coordinates are right and left, okay? Or I did that opposite, but. Let's try another example. This one's probably going to shift in a different way. All right, this one says that we have coordinates 0, 2, 3, 4, and 5, 1. And it does not draw it, so we're going to have to draw it ourselves. There are no numbers, so we will have to be counting. This is the y-axis, this is the x-axis. Pay attention to that. This one says 0, 2, so I start at 0. The y is 2, so I go here for 2. I'm going to actually do it in a different color. Let's call this J because that's what they told us to call it. And then K is at 3, 4, which is here. And again, if you need to count, please count. And then L is at 5, 1. So 1, 2, 3, 4, 5, up 1. And that is L. So we have our original triangle. We have an original shape, a figure. Then it told us to draw the triangle JKL, and we did. Now it says to draw triangle J prime K prime L prime, which is just a new picture after a translation, and we know that this word here means to slide something. 4 units left and 5 units down. So last time we went to the right. This time we're moving to the left. 4 units to the left, 5 units down. Last time we went up. This time we're going down. So let's try that. Let's take each little coordinate and move them. So J, 4 units to the right, to the left. 1, 2, 3, 4. 5 units down. 1, 2, 3, 4, 5 is here. So I'm going to put J prime. K, 4 units to the left. 1, 2, 3, 4. 5 units down. 1, 2, 3, 4, 5 goes here. And I'm going to put K prime. And then L moves 4 units to the left, 1, 2, 3, 4, and 5 units down, 1, 2, 3, 4, 5. Now remember I'm counting on, let me put L prime. Remember I'm counting this. I'm not really looking at the numbers of the places that they are on the board just yet. I will look at them now that I am finding my coordinates. So these are the original coordinates. They put them for me for the original triangle, which we already knew because it listed them out here. Let's find the new coordinates. So J is -1, -2, -3, -4, -4. Okay, sorry. -4 for the x. And then it went down to the 3 on the y-axis. K prime is -1, -1. Oh, I'm sorry, also -3 on that one. So -1, -1. And then L is +1, 1, 2, 3, 4. It went down, so that is a negative number. All right, so let's talk about this, and let's try to find that rule again. Like I said, remember in geometry or any time in math, we really don't write stuff out in sentences. We write stuff out using math language to tell us a story. So over here, we had an original coordinate, which were these, changed to a new coordinate by adding 1 to the x and adding 4 to the y, because we went to the right one and up 4. Now, since we did the opposite this time, and we went left 4 units and down 5 units, we're going to do the opposite here. So the rule for this one would be x minus 4, because we are going backwards this way on the graph, and y minus 5 because we're going down. Now let's just take a second to see if this is right. So if I said that x's subtract 4, I would have to subtract 4 from 0, and 0 minus 4 is negative 4. 3 minus 4 is negative 1. 5 minus 4 is 1. So it worked. And then it says that the y's went down 5 because our picture went down 5, which would change our y value of our coordinate. And I would take the y values and see if I can subtract 5 to get the new number. 2 minus 5 is negative 3. 4 minus 5 is negative 1. 5 minus 5 is negative 4. So that is the two different types of movements you can make. Or not the two different types, but you can either be moving to the right, to the left, up, or down. And anytime we move to the right, to the left, up, or down, we will be changing the rule for what's happening. So anytime we would write the rule, it is actually called the algebraic representation, basically saying we are writing a sentence using algebra. We have a coordinate, xy. It is changing to x plus a number or x minus a number, depending on which way you're going. And then y plus a number and y minus a number, depending on which way you're going. Now the kicker is, or the key is, to know which way you're going for plus and which way you're going for minus. For the x position, if you are adding, you are going to the right. For the x coordinate, if you are subtracting, you are going to the left. We figured that out above. And let's try it one more time, or for the y this time though. This one's kind of simple because if you're going up, you're adding to the y. And if you're going down, you are subtracting to the y. All right, you have one more page, and it is a practice page. Let's work on this one. We're going to do the same thing we were doing earlier by translating coordinates, or by translating pictures and writing algebraic representations using the coordinates to see what we're adding, what we're subtracting, how these coordinates will change when we do whatever they tell us to. This one says translate the image 5 right, 5 units, and 1 unit down. So each of these dots will move to a new unit, 5 units to the right, 1 unit down. So for A, 1, 2, 3, 4, 5 to the right, 1 unit down. This is A prime. B, 1, 2, 3, 4, 5, 1 unit down. D, 1, 2, 3, 4, 5. Oh, 1 unit down. I did not mean to put a dot there. I still had stuff to move. C, 1, 2, 3, 4, 5, 1 unit down. All right, I made my new shape now. It is the same shape. They look alike. They are congruent. Nothing changed about them, not even the way that they were facing. The only thing that changed is the position that it is on the graph. It does have some new coordinates, so let's write those down. Always pay attention to where your origin is so that you can get the right coordinates. So this coordinate looks like it is 1, 0. This coordinate looks like it is 4, 0. This coordinate looks like it is 1, negative 3. Oops. And this coordinate looks like it is, oh, I did those backwards. 2, negative 3. So I'm just going to change that to a 2 and then put the old one right there. Okay, so the algebraic representation will just work this way. Remember, it is going to say that we have a coordinate and it changes to x plus a number or x or y minus, or plus or minus, y plus or minus. And let's figure out what we're doing. So remember, I said that right and down, they have a certain property that we have to use. So I said on my notes earlier that if I were going to the right, I would be adding x plus however much we go to the right. We went 5 units to the right, so I'm going to say x plus 5. And then we go 1 unit down. Y minus a number goes down. So y minus 1. This is my algebraic representation. This is me telling a story in algebra about something that happened in geometry. All right, let's try another one. Translate 1 up, 4 to left. So 1 up, 4 to the left. 1, 2, 3, 4. 1 up, 4 to the left. 1, 2, 3, 4. That is A prime. That is B prime. 1 up. 1, 2, 3, 4. C prime. 1 up. 1, 2, 3, 4. There's D and C. All right. We have new coordinates. This one is -3, +4 for A, and I'm going to write A prime. B prime is -2, +4. C prime is -1, +2, and D prime is -2, +2. All right, the algebraic representation for this move, remember we start with a coordinate. We say x, y is going to change. So our original coordinates changed to these coordinates. And how? How did those coordinates change? Well, they moved to the left, and I know that left and right go with my x. So first of all, let's check our notes to see what happens when we move to the left. When we move to the left, we are subtracting from the x. So x minus, how many did we move to the left? Oh yeah, 4. And if we went 1 unit up, that's actually talking about the y value. If y plus a number, you are actually going up, so I'm going to say y plus 1. And there is our algebraic representation. Now down here for the last 2 practice problems, they actually give everything for us. All we're going to do is write those. It says use arrow notation to write the translation, or to write the rule that describes the translation. We know this as the algebraic representation. So down here we're going to write x, y is going to change, and then we're going to have to figure out what it actually changes to. So I noticed that these little letters over here have the prime things on them, which means that they moved this way. They kind of moved to the right, and then they moved up. Well, that's really nice to us, because if I know that if I moved to the right, I was adding to the x. So I'm going to write x plus, let's see how much they moved to the right. They went from here to here, so they went 1, 2, 3, 4 to the right, and they went 1 up, which means I'd have y plus 1. Now, it's not always going to be y plus 1. I know we had a lot of y plus 1 examples. It could be anything it wanted to be. It could translate however much it needed to move. And here's another example. This one says we have the original triangle here and the new triangle here. I know that because of these little tick marks that they have on the letters. So let's write an algebraic representation. X, y changes to, because I have an arrow, and it looks like it goes to the left. It goes 1, 2, 3, 4 to the left. And my original rule, kind of that I wrote down, says that if I'm moving to the left, I am doing x minus whatever that number is. So I have x minus, I said 4, right? X minus 4. Now, did I move up or down? No, I did not. Which means that y does not change. Y does not add or subtract any numbers because I didn't move. So I'm just going to write y just like that, just because y is left alone. And that is how you do translations.